In the not too distant future, your life and privacy are soon going to be at risk. That's the dangers a new breed of computers represent to how we keep secrets. We live during the information age, generating an increasing amount of data with every passing moment. And conveniently, all of this data lives just a few taps away, connected via the internet. Everything from your precious photo and video memories to an ever-increasing amount of the world's money. In fact, most money is just numbers on a computer somewhere. And just like money and your photos, everything in our lives is starting to be stored virtually online. But what stops someone else from accessing your precious data? And is this something we can do to protect ourselves? This is Shrouded Science, where we explore how science and maths affects our everyday lives. So you might think a password is enough. But how do they work, and why are they at risk by a new breed of computers? Let's start by talking about how passwords actually work. They're simply just a secret sequence of characters that can confirm a user's identity, and surprisingly they have existed in some form for millennia, like the ancient Roman guards who used secret codes to allow entry to a camp. But unlike the Roman secret codes, most of our world lives online, and physical verification is not possible. So we need a modern code. And this spurred the work of Fernando Corbato, a computer scientist at MIT, who devised a credential checking system for the use of the shared computer systems. However, a password is not enough. They function similar to keys to your home. Each key has a groove, and it represents a distinct way of moving pins within the door mechanism that allows it to unlock. But keys are fallible. There are ways to circumvent their protection. For example, someone could try to pick a lock, which is similar to just guessing a password. We can somewhat circumvent this by using a more complicated lock, and this is why you're often advised to use complicated passwords. However, someone could also take an impression of a key and simply copy it. And this is usually how passwords are compromised. When you're trying to be verified, you are essentially sending a secret sequence across the open internet in a data packet. Somehow you need to make sure that no one can peek at the data packet before it arrives to its destination. And while in real life you can hide your keys, you can't shepherd your data packet to the destination. So somehow you need to disguise its contents so no one else can see it. This is what is known as cryptography. It's the study of how to ensure secure communication and allows for passwords to arrive safely at their destination. And we see evidence of cryptography as far back as 1900 BC, where secret non-standard symbols were used to pass information that only insiders could read. Or there's techniques such as Caesar's cipher, which shifts the alphabet and recodes the word, so the word subscribe becomes this jumbled mess. But these methods are only as strong as their key. In cryptography, a key is a piece of information that can be used to encode or decode data. Luckily, we have developed incredibly complex methods of encryption like SHA-256, which will take longer to randomly guess than the life of the universe. And these methods function on a few simple principles with some complex mathematics under the hood. Leave a comment below if you're interested in knowing more. The most common kind of encryption today are symmetric methods. Here the same key is used to both encrypt, which is a process of disguising data, and decrypt, which is a process of revealing data. This key is held by both the sender and recipient, so when you send a message across the internet, it's encrypted with the key, and the original message can only be decoded by using the same key. To ensure the security, keys tend to be incredibly long and hard to guess by random chance. And in addition to these techniques, there exist other methods such as asymmetric encryption. So far everything seems pretty secure, right? It would take billions and billions of years to crack the code. So what's the catch? Well, as I mentioned, an algorithm exists that can crack even the toughest form of modern encryption. This is what's known as Shor's algorithm. You see, the mathematics behind modern encryption revolves around multiplication and factorization. We can see that it's incredibly easy to multiply two numbers together. However, when we start using very large prime numbers, the resulting product is incredibly difficult to break apart, and trying to randomly guess these pairs of numbers would take an incredible amount of time. But Shor's algorithm devised a unique way of using the principles of quantum mechanics to speed up this factorization. It's incredibly complex for a short video, but theoretically it does work. So if the algorithm exists, why aren't our passwords just failing? What's the catch? Well, currently we don't have a capable machine to run Shor's algorithm. This is because to use the principles of quantum mechanics, you need to use something that's called a quantum computer. Regular computers code information using zeros and ones, but quantum computers use something called a qubit to represent information. This also has the same possible states as a bit, 0 and 1, but the added complexity of superposition means that it could have a state between 0 and 1. And surprisingly, these computers do exist. However, currently they're too weak to run Shor's algorithm. But looking back at the development of computers in the past century, it's just a matter of time that powerful quantum computers can be used to finally break encryption. So what's being done to safeguard this information? Well, a new field budding from cryptography has emerged. This is post-quantum cryptography, and it revolves around developing algorithms that can be used to encrypt and decrypt data in a way that even quantum computers can't breach. And did you know there's some algorithms that are using the principles of evolution to learn? Check out this video on genetic algorithms and consider subscribing for more content. Thanks for watching.